I'm super excited to introduce our closing keynote speaker because Jessie Frazelle has a ton of insights into absolutely everything to do with containers, security, security in containerized worlds. Oh dear, I think we live in one of those now. So give it up for Jessie Frazelle.
Hi, I'm like super stoked to be here. Usually I've just like watched this from my Twitter feed from wherever I was living at the time and like super having FOMO of not being here. So I'm very excited that I'm actually here this time and that I get to talk about things that I can like totally rant about. So I'm Jess. If you don't know me, I've contributed to a bunch of open source projects, mostly around containers, so like Docker, Kubernetes, and then Go I also contribute to because that's like one of the main programming languages that I use, and then runc, the kernel. It's not that cool. So like other alternatives titles for this talk are like the past, present, and future of usable security and like making security invisible, because containers really do a lot to kind of help us out in ways that we never really had like these security mechanisms readily available to us. And I think that there's a lot more that we can do to make it easier and more usable. So kind of a timeline of what I'm going to do is talk about like the past, the present, and the future of usable security, and hopefully trigger you all with some terrible things from the past. So spoiler alert, the past is not exactly usable. Probably already knew that. And the present and the future is kind of about how containers make this all more usable, and then some crazy stuff that we could do to even make it more and more usable. So starting with the past, a lot of things kind of make users jump through hoops, like getting and updating SSL certs, which, you know, like Let's Encrypt has helped with a lot now. Poorly written APIs, which I will get into more depth on a specific example later. Unusable tooling around keys, so like GPG. I was in charge of the Docker apt repository for a very long time, and just any sort of hash sum error made me want to pull my hair out, because it was like some undefined thing that was actually just wrong with apt in general, but it all has to do around keys and all this like stupid stuff, and then signing it, and then there was like some sort of checksum mismatch at one point, and like when people can't install a project as big as Docker, hell has broken loose. Like that shit hits the front page of Hacker News, and it's like super stressful for the person who is in charge of it. And it looks really bad when the rest of the team is like, what the hell is happening? And you're like, it says hash some mismatch. So I'm doing what I always do for every error. So yeah, GPG just has like one of these reputations for being awful, and just like everything around it is pretty bad. Like the user interface is hard to use, it's hard to rotate keys, it's hard to revoke keys, blah, 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 blah. I wasn't actually supposed to say blah, 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 but it was there, and I like could see that coming. Okay, so there's like a point at which security actually comes at expense of convenience. So a lot of people have almost taken it too far to the fact where it's hard. So setting up a YubiKey is actually simple and hard at the same time, depending on like what OS you're on. So like on Linux, you have all these sorts of options with libraries and stuff like that. There's like a bunch of various examples for like convenience in place of security. And I actually think Chrome makes a lot of good assumptions when it comes to these decisions. It's always almost good to err on the side of user convenience, and then to give another way out that will be more secure but less convenient, only because like most users will just turn things off if it doesn't work out of the box. So this is kind of the example of the API being bad. So Dave Cheney, who I love when he gets like mad about anything, I'm like there for that. So he was using, I guess, the duosec API, which is like two-factor auth, And they return 200 even if someone denies the request. So apparently you have to like decode the JSON that comes back and then actually see if it was accepted or not, which is literally the point of HTTP status codes. It's like, why even put that in the body? There are codes for that. And if you even wanted to obfuscate it, you could use a different code. But it's like, at the end of the day, they have what's happening in the body anyway, so it doesn't really matter. So my response was obviously, it's because someone in security designed it, not like a sane person. So the lesson here is that like if security engineers and software engineers work together, they could create like amazingly great things. And I think like a lot of what the industry is getting towards is this. And that's why we're getting a lot more usable tools and the present is a lot better. So I really think like keeping this in mind, and a lot of my friends that work at other companies, they're like, yeah, we're not going to have the security team design it. We'll design it, and then they can do whatever they want with it. But like if you compromise together and work together, you know, each of these teams have their strengths, and they can really like shine through in the like resulting product. So the present. We live in a containerized world, or maybe you all are like just hearing about containers and you're trying to get like your company to switch to them. So we're trying to get there. Like I've been to a bunch of companies where they are not even close to containerized worlds yet. But the goal is to get there. Monoliths, yay. So just like a brief intro to containers, it's made up of Linux C groups and namespaces, and these are kind of all the options that you have. And then on top of this, you can actually stack all these Linux security modules, and that's kind of like where you're going to get your isolation from. You also get isolation from namespaces and C groups, but on its own, it's not really great at being super isolated in almost a sandbox type of way, which I'll get into later. But I ended up writing a blog post about like the differences between containers, zones, jails, and VMs, because a lot of people ask me this question, I think almost to trigger me, and it doesn't. I actually really like zones and jails and VMs. They each kind of have their use, which was the point of the entire rant on the blog post, and so that people stopped asking me. So yeah, containers are kind of made up of, like I said, C groups, namespaces, and LSMs, but zones, jails, and VMs, they're kind of like these first-class concepts. So you can break containers up in interesting combinations where, you know, you're using a specific C groups and specific namespaces, but you're leaving out, say, like a PID namespace or a net namespace so that you can then use and see all the processes on your host, and then also use the network namespace of your host. So you can kind of do this mix and match combination, which is a feature that a lot of people don't know about. But you can use all these things in Docker and in other container runtimes, and it's pretty cool. So if it was a first-class concept, you wouldn't necessarily have this type of like control over things, which I think is why containers are awesome and why I run them everywhere. So what is a sandbox? This is kind of one of my favorite descriptions of a sandbox. Whoever came up with the term sandbox obviously doesn't know how sandboxes work, because sand, like, as you know, gets everywhere, especially it being the summer. If anyone went to the beach, you bring sand home with you. Like, I was finding in my hair for like 4 days after. It's terrible. So sandboxes provide a net reduction in attack surface, which is like the opposite of what a real life sandbox does. So if you compare your code executing inside a sandbox from outside the sandbox, there should be less things possible inside the sandbox than outside. That's kind of the whole point of the sandbox. So the best example of this is obviously Chrome. They have like a ton of well-respected engineers working on it, and the community really respects like the sandboxing that it does as a security mechanism. So how are they doing this? On Linux, they actually use a lot of the same primitives that containers use. So each tab in Chrome, if you didn't know, it gets its own PID namespace. So just to say what a PID namespace is real fast, it's used to isolate the process ID number space. So basically, this is to make sure that any other tab can't know about processes in other tabs. So say you're logged into Facebook on one tab and some super sketchy site in another tab, and you don't want your, Facebook cookies or, ad suggestions to be shared, or anything like that, or like people crossing the like boundary of a tab, this makes sure that that happens. So they also use unpublished user namespaces for the actual sandbox and network namespaces as well. So these are all things that we also have in containers, which is super awesome. And then on top of that, they use Seccomp VPF, which I'll get into how this works in containers after. But if you look in Chrome, you can actually see all the things that you're using. The SUID sandbox is like a legacy thing, and it's super shitty. Or at least that's what I gained from the documentation. I suggest you go read it if you like want to fall asleep on a plane. But yeah, you can just make sure that you're using all the cool things. So what is Seccomp? Seccomp is actually secure computing with filters. And it allows people to write BPF programs that determine whether a given syscall will be allowed or not. So some of you might be familiar with BPF for like tracing and stuff like that, but it actually has a lot of different use cases, and Seccomp just happens to be one of them, just like tracing in virtual networks. So if we apply all these same principles of kind of the Chrome sandbox and all these Linux primitives that we already were using on containers to containers, we can kind of determine if containers are a sandbox, which they aren't out of the box, which I also kind of covered in my blog post on the differences. But they actually like can be a sandbox if you combine all these kind of LSMs together with the right configuration. So this is what we tried to do by default in Docker with like the default AppArmor profile and a default Seccomp profile. But you can always like make them more specific and actually take out a bunch of things that we were just allowing because it's on by default, so it has to work for a bunch of people. So we added Seccomp to Docker, and it allowed you to like basically give any sort of custom profile at first, which no one's going to write these because if you actually look, you have to like know every single syscall, which is just absurd. So let's talk about usable. That's not. So yes, can it be on by default? It is. In Docker, we ended up writing a custom Seccomp profile, which made me realize how terrible and awful this is, because it literally just specifies every single syscall that's allowed in a container. And like to do this, I went through like all the past like big CVEs around you know, escalating privileges or popping out in namespaces, and we kind of tried to disallow all the things that had bad reputations in the past. So it blocks a bunch of bad stuff. Kind of the main ones are add key, keyctl, and request key. So these all have to deal with the kernel key ring, which is not actually namespace. It's like this weird hybrid thing. So you can actually, like, if you're in one container, that's the process inside the container is running as root, and then you're in a different container, you can actually see things in like proc keys that you probably shouldn't see. There's been like not exactly exploits on it, but there's some interesting things. So then there's clone. So clone has a bunch of different flags you can give it. So the ones that we blocked were for cloning user namespaces, and then any sort of other clone flags associated with that. So that basically just makes sure that you can't, like, inside a container, unshare, like, or clone a new user namespace, because user namespaces kind of have this terrible reputation for being super shitty, and there's a bunch of weird behaviors with other aspects of the kernel and user namespaces that a lot of people don't know what's happening with, so a bunch of vulnerabilities come up, like, through there. So we also did the same for share there. But there's a bunch of other things that we blocked, and then there's an entire document on it if you want to read it. It's super boring. So hardening features of containers, like applying LSMs and these hardening features like Seccomp, AppArmor, SE Linux, it's a lot easier with containers because you don't have to worry about applying it on the process itself. There are applications that use Seccomp, like Chrome, and then I think Elasticsearch or one of the databases uses it because we had to make sure that allowing Seccomp to be formed from inside a container had to be allowed. So it was always kind of hard to do on your own. You'd have to write all the like programmatic logic for setting it up. But now with containers, you can actually, if you really want to, you could write your own custom profile, or it's just there by default. So like the access to these things just became huge, which is really nice. And this is like a huge benefit of containers. And saying defaults are enabled so that you kind of almost don't have to think about it, which is the whole point at the end of the day, like making it secure for 99% of people, and then giving the rest of the world the ability to either turn it off if they don't need it, or customize it as they see fit. So of these things, one of them is AppArmor, which is just a security module. It can block, allow, deny, like writing to certain files, certain system functions. It doesn't really handle all of them. It does like some networking ones, mount. It has like this weird like pseudo language that's super horrible because all things that are security are horrible. So it's horrible to maintain. And actually, Erica did a lot of the work in Docker on AppArmor. That like I don't even know how that's done. So yeah, one of the like same defaults that we had were like not writing to proc or sys or procsys, and preventing mount inside containers. So in Kubernetes, this is actually beta. That's why that says that. I meant to delete that. This is kind of how you would set it up in Kubernetes if you wanted to. In Docker, you don't have to worry about it, but we're actually like turning this on by default so that you don't even have to do this in like future release. But for right now, since it's in beta, you just add like an annotation. And it really like honestly shouldn't break your container. And if it does, that's actually a bug you should file, because there's a problem with the default then. But it's been in Docker long enough that you really honestly don't have to worry. So Seccomp is different in the fact that it only does like allow deny of syscalls. So the same default as a whitelist. It's basically the same thing that's in Docker. And you do it the exact same way as AppArmor. You just kind of put it in the annotation if you're using it with Kubernetes. So no new privileges is kind of a new one. This is just a flag that kind of, it will take anything from fork, clone, or exec and prevent new privileges from being added. So say you have a set UID binary inside a container, and you say no new privileges should be set. If that binary starts as user like 1000 and it tries to escalate its privileges because it's a set UID binary, it won't be able to. It will just stay as user 1000, which is really cool. And you should definitely make sure that this is on in your containers. This isn't on by default in Docker, but we're turning it on by default in Kubernetes in a way that will not block set UID binaries, because that is the fear, and we cannot break people, which is the whole point of this talk. You have to be secure but not break people, because when you break people, people get mad, which I'll also show. So yeah, how you would do this in Kubernetes config is we actually just flipped it so that it's allowed privilege escalation, so that it's not like a defaulting to true. It defaults to false, so you don't allow privilege escalation, and then it turns no new privileges on, which is kind of confusing, but it makes more sense if you don't know what no new privileges is and you just ignore that entirely. So security context is kind of like where all the like settings for these things in Kubernetes are, and there's a bunch of like controls that you can do to make sure that containers are not run as roots, and to add or deny specific capabilities from your containers, to set the root file system as read-only, and set SE Linux context. So doing any of these sorts of things on your applications that are just like running on your host, not in a container, would be super difficult. Like you would need some sort of custom framework for it, which is why containers are awesome. So it makes it just like all these sorts of things kind of insanely more usable and easier to access. And this just basically shows like how you would do this in a config. It's all just like YAML, yay. Okay, so along with containers come the container-specific OSs, which have a lot of cool features in security as well. And they also like are the best things for running containers. So if you're running containers today without container-specific OSs, I suggest you switch just because you get a bunch of these features for free. So the way CoreOS works, and then the Google Containerized OS, which is basically like the same thing, but if you spin up a GKE cluster, it all uses that. It's a read-only user, and then you get stateful read-write on root. But this basically just ensures that you are not really putting anything in like user bin, and your entire file system is not really executable except what's in user bin and then what you execute in containers. So it kind of forces you to run everything in containers, which I love because I do that on my desktop, which is also why I run CoreOS on my desktop. Super insane, would not suggest that, but these OSs are cool for servers. Auto updates, so you can automatically update your kernels, which was always like a huge pain for any sort of like production environment. Like when you are running thousands and thousands of servers, getting a kernel patch in for some sort of huge bug like Dirty Cow, say, would be insanely difficult. But with auto updates and then also the auto updates feature in Kubernetes, you can basically just update your entire infrastructure with the click of a button, which is super, super cool. So CoreOS has this and like the Google Containerized OS as well. It also uses, Omaha is what ChromeOS uses for auto updates, so like it's good. So CoreOS also has trusted computing with TPM, so it's basically making sure that the root file system that you boot along with DM Verity, it makes sure that the root file system that you boot is actually the one that you want to boot and no one has modified it in between, which is also features in ChromeOS, which is kind of how they beat the whole like evil maid problem. So this is all really nice for your infrastructure, and you get it out of the box with like any of these sorts of containerized OSs, which is super, super nice, and kind of why also containers rule and make your infrastructure more secure. So that doesn't even begin to cover like all the things that you can do with containers presently, but it's all the things that I really know about and work on personally. But there are a bunch of other new features in Kubernetes with regards to like least privilege escalation on nodes and stuff like that as well. So the future, I think that we can actually take this all a step further. So if you think about like how accessible we made kind of these security features that no one really wants to use otherwise, like AppArmor and Seccomp, and it's now accessible to use them in containers, and people are kind of starting to understand what they are. If we took it to another level and actually started adding it to programming languages so that it could just be almost compiled in at build time, that would be super cool too. So this is like one of my really weird ideas that I've had for a while. So it's basically just going a step further than adding it to containers. I wrote like a proof of concept for this where it takes your Go code. I just use Go because I know Go, and it's a compiled language. So it takes your Go code, and then it will actually, at build time, generate Seccomp filters that will be applied on run. So this is a lot different than those like AA-gen-prof, if you ever use that. It's a horrible tool. But that actually kind of watches as your application is running and tries to generate a perfect filter. This is different in the fact that it does it at build time. So it actually looks at all the code that you're using, and then it can create a filter from your code. So if you have any sort of dead code in there, it will be applied in the filter, whereas at runtime, you actually never know if you're going to hit it at all, which is cool. And the Go build toolchain, the way that the linker works, this was actually very easy to make a proof of concept for. So why generate Seccomp filters at build time? All these things that basically generated any sort of security filters or profiles at runtime has been done in the past and failed. There was SE Linux and AA-gen-prof and all those things. Some things always missed in the testing phase because you can never actually make sure in your testing phase unless you have some crazy 100% code coverage, which yay for you, that you're hitting all the functions. So there's going to be some function mess up, it's going to run in prod, and then people are just going to turn it off, which is not good. This is what we've been trying to avoid this entire time. So that's kind of why doing it at build time is way better, and these are the horrible examples. So kind of just to give just to really set this in. So say like a user starts profiling Chrome, and they're doing like AA Gen Pro for some stupid SE Linux thing. So they're like, I'm going to run Chrome, and then I'm going to run this like profile thing to generate something. And they open some tabs, like maybe Gmail or whatever. And that's it. That's all they do. And then they're like, OK, I'm going to take this generated profile, and then I'm going to apply it to Chrome, and then I'm going to reopen it and see if it still works. So they do this, and then they try to play a video, which maybe, wants hardware acceleration or something, and that was not like accounted into the profile itself. And it's not going to work, so they're just going to turn it off, which is the problem with, the AppArmor generations and SE Linux generations. So just to avoid this entirely, doing it at build time, knowing all the code that it's going to be run, and then including that in the filter would make this entire problem disappear. So yeah, I wrote a proof of concept, but it like slightly failed in the fact that there's like 3 ways that this will never work. Well, it could work. OK, so I'm very stubborn. In Go or any sort of programming language, if you're going to exec some other program, you cannot account for that, because you're back at square one. Like, how do I then profile this program that I'm now execing? And I happen to do this a lot in Go code, so it kind of sucks for me. You could obviously just turn it off when someone execs something else, but that's like not really a great default. So that's number 1. Executing other binaries sucks. Go just added support for plugins, but a bunch of other programming language has plugins. So like if you're doing something in C, even like a DL open, it's the same problem. So if you open a plugin, you don't really know what that program's doing. Granted, the plugins are actually generated also, or like built by the Go toolchain. So we could, like put something in the header or something and then read it later and then use that at runtime as well. So this one's actually a solvable problem because we know where that came from, whereas with like executing an arbitrary binary, you don't. And then the third problem is if you're just going to execute some arbitrary syscall, like I have no idea what the hell you're going to do if you're just passing in arguments. And this one's actually not a huge problem because nobody really uses syscall.raw syscall. But I'm sure in other programming languages there's something equivalent. And it would also be a problem there. So yeah, it's not exactly perfect. But the idea is there, and it could be done eventually. Rome wasn't built in a day. And Edison made many unsuccessful attempts at inventing the light bulb before he actually did it. So this is just a kind of interesting attempt. And then I'm sure there will be a way to do this in the future. And we can actually like make binary sandbox themselves, and then the user wouldn't even have to think about security. It would be literally invisible. So we basically covered the past, which is gross, the present, which is good, and there's a lot more that I didn't even touch on about how great containers actually make security, or adding security to your organization easier. And then the future is actually bright if we like keep continuing to work together and collaborate as a team with security people, and then build usable tools. So I just want to reiterate that there is a point at which better security comes at the expense of convenience, which, yeah, it's always a battle in the balance between the two. And haters are always going to hate. So like even in Docker, after we added the Seccomp feature, it wasn't enabled in Ubuntu Trusty or Debian and Jessie because the stable libseccomp dev packages for those repos are like one release behind, and they have this weird bug with generating filters, so like blah, 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 blah. And Debian packages, you cannot update those in stable. Like we tried, and they said no. And then that was even before they were in backports. Then they added them to backports, which then meant that we were never going to get them in stable. And I was just like, shit. So we didn't have it turned on, and then this huge issue with a bunch of like comments, and like very angry people were commenting on it, and they were almost like saying to like, they were almost insinuating that like we weren't trying or like that we didn't care. And I was like, we wrote this feature because we cared. And also like, if we actually break Docker for something like that, where we like try to grab something from backports or install something that wasn't going to work, then it would be on the front page of Hacker News, and I would be the one to blame when the apps repo was down at the time. So it's like a very scary situation to be in. So it's like nice when people actually like consider that or think about that problem to begin with. But people are always going to be mad if they don't have their way. So it's all about finding the right balance between secure and usable and not breaking your users, because then you just lose user trust entirely. And that's all I had, so thanks.